Today we're going to talk about this last part here, example 14. Now they have changed things on me since I printed this out. So instead of going to well, you can still go to statlet.com. I'm going to show you how to find the link for the correlation and regression. It's a little bit counterintuitive. So I will go ahead and this is what you'll see if you're at statlet.com. We need to go to, actually it's the ones for our books. So click on applets for the practice of statistics. Should take you to this page here. This is your website for your book. It's the 6th edition. We use the 5th edition, but it still has some good stuff on here. Scroll down until you see statistical applets, and then you'll find the one that says correlation and regression. That's the one I want you to use. It should look like this. And if you want to type in this whole URL, you are welcome to do that. So there's what we're looking for. What I want you to do is follow the instructions in question 1, and you can click in here and it'll tell you how many points you've put and what the correlation is. Okay, so go ahead and put as many points as you need to, and actually try to keep it to 10. And we want to have a correlation of about 0.4. So try to get this as close to 0.4 as you can. Here's my correlation of 0.4. I should have also mentioned if you don't want the point there, you can just move it around until you get it to where you want it to be. So let me put this back at 0.4. Almost, that's going to be good enough. Okay, so there's my correlation of 0.4. And then you'll want it to show the least squares regression line and the mean X and Y lines. All right, so this is what it looks like. And then I want you to go ahead and sketch your graph below where it gives you some space there. Sketch out what you have. All right, so it's important to note that these are your X values going this direction, the X axis. So this line that's up and down, that would be your mean X value. And so what that's taking is it's taking all the X values of your data points, finding their average, and it's going to put a line right through there. Okay, same thing with the line going this direction. Your Y values go up and down. It takes the mean Y and plots it on that line right there. Okay, that's what's happening. So let's look at part 2. Number 2 asks, it gives you some situations, and it's asking you what's happening here. Okay, so you're going to, on your own here, just put a data point in. So for example, in part A, it asks you to add a point on the far right side of the graph on this line for the mean of Y. So I would add a point by clicking here. And then I'm going to see what happens. If you click on that point again, it will disappear. So if you want to, you can kind of click back and forth and see what's happening. I want you to do that for parts A, B, C, and D, and just write down what happens once you do that. All right, I have what happens to mine over here to be very similar for what happens with yours. So what's happening essentially here for A and B, I'll go ahead and draw those on here. So A would be somewhere over here, B would be somewhere over here. And when you're doing that, you are essentially tilting the line. So when we have our least squares regression line, looks maybe something like that, and you add a point over here or over here, you are tilting that line. Your slope is going to change, your y-intercept is going to change, and your correlation is going to go down. If you are adding a point where for C and D, C is down here and D is up here, your slopes should stay the same. However, your y-intercept and your correlation change. Oh, and this one, I don't know, this should say decreases. Yeah, that's better. Increases, decreases. Yep, okay. Should be decreases. So when you're adding the points above and below, all that's happening to your line is it's being shifted up or down. It's not tilting. So I'm going to add here for C and D, it is going to either lift or pull down the line. but it doesn't tilt. It doesn't change the tilt. The slope stays the same. The correlation does decrease on all of them because these new values are outside the pattern. And anytime we introduce a value outside of the pattern, the correlation is going to go down. The last question we need to answer on this page is question 3. And it asks us which outliers had the greater impact, the horizontal or the vertical outliers. And I want you to think about it for a second, and we'll talk about it here in just a minute. All right, so when we're talking about the greater impact, it is going to be the horizontal outliers, not the vertical ones. The vertical ones, again, were these last two. The horizontal ones really did change more than we saw here. The slope didn't change when we talked about adding things on that vertical line. Just the other two things did. So for the first ones, the horizontals, the slope is changing and the y-intercept is changing. More is happening. Okay. Horizontal are greater leverage points. So we say that they have more leverage. And the reason they have more leverage is they are to the left and right of the center. Okay. So whenever it asks you for the greater leverage point, you're always looking for the horizontal outliers as opposed to the vertical outliers. Okay, let's look at this example on the next page here, example 15. Okay. Example 15, you can take a second to read the question, look at part A, and then we'll talk about it here in a second. All right, so let's look here. We need to describe the influence that the point representing the LA Dodgers has on the equation. Now, you don't know which one that is, but let me tell you. The LA Dodgers are these guys out here, and then it's going to ask us for the Cleveland Indians, and they are this point right here. So LA and Cleveland, there's the 2 points. So the question is, how are these going to influence? LA is on the far right and below the least squares regression line. So I'm going to put that on here. Far right and below. So if we're looking at over here, it is on the far right and it is below. So it will decrease the slope and it will increase the y-intercept. So the slope and the y-intercept will increase. All right, so let's talk about, that was for the equation. Now we're asking what effect will the Cleveland Indians have on the standard deviation of the residuals and on R squared? Well, Cleveland has a really large residual. Okay, if we think about the residual for Cleveland, that's really large. So it's going to make the standard deviation a lot larger. It is further away from the line. So since it has a the standard deviation of residuals, it will increase S. It is going to make R squared smaller. And again, same thing, it has a large residual, so less of this can be explained by payroll. Okay. So R squared will decrease. Alrighty, the very last thing I want to talk about is this last example, example 16. Example 16 does not give us the entire data. It gives us a certain part, certain information, but not all of the data points. So we can't just type things in our calculator and have our calculator calculate the least squares regression line. On your formula sheet, you will see that there is, these formulas are on there. I've written them exactly as you'll see them on the formula sheet. You're welcome to write them here, put a little star around them so you remember that these exist. This is another way of writing the equation of the least squares regression line. I do give you all of the information that you need. This isn't a super prevalent topic, but I wanted you to at least see that it is possible. So go ahead and pause the video and use this information. And again, just kind of plug and chug here into your least squares regression line to figure out the equation that predicts height from foot length. All right, I have my answers to show you here. You can check your work against mine. One thing I do want to point out is that even though I have my equation here in terms of y and x, leaving your equation in terms of y and x is not good enough. You do need to put the context with them. So if you didn't want to put y and x, I could have over here wrote that y was equal to the height and x was equal to the foot length. I think it's easier when it's written in this equation right here. So I will rewrite my equation to have those two variables, although you are welcome to use this as an option as well. Here's how you make the equation of a least squares regression line when you are not given the entire data. You would need to be given enough that you could figure out these things. Okay, I wouldn't just throw you in there and say, figure it out. I would give you a lot of information like it's given in here.